Hey everyone, welcome to Space Tech Talks. If you're curious about the universe, from its mind-bending mysteries to its jaw-dropping wonders, you're in the right place. Today, we're diving into one of the most fascinating topics in space black holes. These cosmic beasts have captivated our imaginations for decades, and for good reason. They challenge our understanding of gravity, space, and time itself. We're going to explore what they are, how they form, and what would happen if you got too close to one. Buckle up, because this is going to be a thrilling journey. First things first, what exactly is a black hole? Imagine a region in space where gravity is so strong, so intense, that nothing, not even light, can escape its pull. This is what we call a black hole, a mysterious and fascinating phenomenon in the universe. Now you might wonder, how does something become so powerful? What processes lead to the formation of such an extraordinary object? It all starts with a star, often one much more massive than our own sun. These stars are the birthplaces of black holes. When these stellar giants reach the end of their lives, they exhaust their nuclear fuel and can no longer support themselves against their own immense gravity. This is a critical phase in the life cycle of a star. The core collapses in on itself, and if it's massive enough, this collapse continues indefinitely, creating a black hole. This process is both awe-inspiring and a bit terrifying. So we've established what a black hole is, but did you know they come in different sizes? Astronomers classify them into three main categories. First up, we have stellar mass black holes, formed from the collapse of massive stars. Next, we have the supermassive black holes lurking at the centers of galaxies, including our own Milky Way. And then there are the more theoretical types, like intermediate mass black holes and primordial black holes, thought to have formed in the very early universe. Now you might be wondering, do all stars become black holes? The answer is no, not all stars end up as black holes. The fate of a star depends on its mass, which plays a crucial role in determining its ultimate destiny. Our sun, for example, will eventually become a white dwarf, a small, dense remnant of its former self. But for stars much more massive than our sun, at least 8 to 10 times more massive, things get a lot more intense and dramatic. These stars explode in a spectacular supernova, a brilliant and powerful explosion that outshines entire galaxies. If enough mass remains after the explosion, the core can collapse under its own gravity into a black hole, an object with an immense gravitational pull. Stars over 100 times more massive might skip the supernova stage altogether, bypassing the explosion. These extremely massive stars can directly collapse into a black hole, forming one of the universe's most mysterious and powerful objects. What would happen if you were to fall into a black hole? It's a question that has intrigued scientists and space enthusiasts alike for decades. It's a question that's both terrifying and fascinating, blending the realms of science fiction and astrophysics. As you approach a black hole, you'd experience spaghettification, where the gravitational pull stretches you out like a strand of spaghetti. This is due to the immense difference in gravitational forces acting on different parts of your body. If you were to fall into a supermassive black hole, the experience might be different and perhaps even more surreal. The tidal forces near supermassive black holes are less intense, so you might cross the event horizon without immediately being ripped apart. This gives you a brief moment to observe the bizarre surroundings. Beyond the event horizon, the laws of physics as we know them break down, leading to phenomena that are beyond our current understanding. Time and space warp to a degree that's impossible to comprehend, creating a surreal and mind-bending experience. It's thought that you'd eventually reach the singularity, the point of infinite density at the heart of the black hole, where all known laws of physics cease to apply. Now I know what you're thinking. After hearing all that, you might be tempted to swear off space travel altogether. But black holes are not cosmic vacuum cleaners roaming the universe, sucking up everything in sight. A black hole's gravitational influence is only significant within a certain radius. The nearest known black hole to Earth is about 1,000 light-years away, a comfortable distance on cosmic scales. So rest assured, we're perfectly safe. And that's a wrap for today. I hope you found this deep dive into black holes as fascinating as I did. These cosmic enigmas continue to push the boundaries of our understanding of the universe. If you have any more questions about space or black holes, drop them in the comments. I'd love to hear from you. Don't forget to like, share, and subscribe for more content like this. Until next time, keep looking up and stay curious.